Hello. This is the problem that you had asked for about quadratics and completing the square, and ultimately where we're going with this is to the vertex form of a quadratic. I apologize that it took me over 24 hours to get back to you on this. I think the whole nation is starting to do what at Southern New Hampshire University we do all the time, and so I am fighting with servers, and I'm having a hard time getting my videos uploaded and from there. But let me see if I can clear this up for you. I am making a few assumptions, so I do need you to tell me if I have missed something. I believe, based on what you've told me and what I'm seeing right here, that this was the original equation, that you got something, that you had something where you had a function f of x equals 3x squared plus 12x plus 5. And then your directions were to put that in vertex form so that we could identify the vertex of this quadratic. So if that is not the case, email me back and give me whatever information that you have on that. The problem, when you were given the problem, you were given the problem in what we call standard form. In standard form is ax squared plus bx plus c. Okay, we start with our highest exponent and then we move down to our constant. This is typically what we deal with anytime that we are factoring. Like, that is the form that we want it in when we're factoring, and that's usually we set it equal to 0, we find our zeros or our roots, our solutions, and that's how we go. However, we can take a quadratic and we can put it in what we call the vertex form. We do have to do the process of completing the square, and it is a little bit different sometimes. And it is sometimes a challenge because it doesn't seem as natural as some of the other stuff that we do. So what we have right here is we have the original problem, 3x squared plus 12x plus 5, and we are moving in the direction of vertex formula. So this is where we want to go. And once I get it in this formula, the h and the k are my vertex. And so that is why that is helpful. So right here, we are going to get started. So the first thing that I have to do when I am working out this problem is I need to separate my terms that have an x value in it. So the first thing that I'm going to do is I'm going to have my 3x squared plus 12x together. And then I'm going to have that plus 5, and I'm going to put that plus 5 kind of over here. We're going to deal with that separately. So I'm going to go ahead and put this in parentheses just so we can show our two very distinct parts. Now, in order for me to use the vertex formula, this x right here has to have a 1 in front of it. Now, I don't have a 1 in front of it. Right now, I've got a 3 in front of it, but I have to have a 1 in front of it. So what I'm going to do now is I am going to factor out that 3. Okay, so I'm going to have f of x equals, and I am factoring out a 3. So I've got 3 on the outside, and I've got x squared plus 4x on the inside. Okay, so I factored out a 3. I factored it from both the 3x squared and the 12x. The 5 I'm leaving alone. I'm not dealing with that 5 at all because that's outside my parentheses. Now, the process that I'm going to do now is called completing the square. I'm completing the square. So I have 5x squared plus 4x, and what I want to do is I want to take 1/2 of 4. 1/2 of 4, and 1/2 of 4 is 2, and then I'm going to square that. So 2 squared. So I've taken half of 4, 1/2 of 4, that's 2, and then I've squared that 2. Okay, so I am adding 4 right here. Now, this is the part that confuses students and is likely where you got confused. Anytime that we are dealing with an equation, we have to keep that equation perfectly balanced. So let's think back to earlier in the semester. If I had 4x plus 3 equals 12, and I was solving a very straightforward linear problem, I would have to subtract 3 from both sides. I could subtract 3 from both sides because I was keeping it balanced. And as long as I did it to both sides, I was in good shape. Well, here, we still have to keep our equation balanced, but we're only talking about one side of the equation. Okay, we have an f of x over here. So I can't add anything to the other side of the equation. I've got to keep everything on the same side. So I added this 4 right here. This 4 got added. But I didn't just add the 4. I added 3 times that 4. So 3 times 4 is actually 12. So on this part of my equation, this part right here, I actually added a plus 12. Okay? 3 times 4 is plus 12. Now, I've got to keep this balanced. So typically, if I was solving this, if I added plus 12 on one side, I would just add plus 12 on the other side. But what's happening here is we've only got one side to work with. So I need to deal with this side of the equation, and I have to keep it balanced. So because I added plus 12 to the part that's in parentheses, I have to subtract 12 on the other part to keep everything balanced, to keep it all balanced. So what I actually have is 3 times 4 is 12. That's what's been added here. Then I'm going to subtract 12 here because positive 12 and negative 12 is 0. Okay? Now, what I'm going to do is I have f of x. Go back to my other pen. So I have f of x equals 3. Now, I want to get this x squared plus 4x plus 4. I want to get this part to look like a binomial squared. That's what I'm doing right here. So I am going to keep my 3, but then I'm going to factor my x squared plus 4x plus 4. That factors very nicely to x plus 2 squared. So if I FOILed x plus 2 squared, I'm going to get x squared plus 4x plus 4. That's where that comes from. Now, by design, I made that a perfect square trinomial so it could factor. Then outside that, I have 5 minus 12, and 5 minus 12 is negative 7. So what I have done is I have used the process of completing the square to get this into the vertex form. And so my vertex, and if you look at your original equation, it's x minus h squared, and I have x plus 2 squared here. So my vertex is negative 2, negative 7. Now, I don't know that you had to go that far and identify the vertex, but you did want to get it into vertex form, which is what we have right there. So if that is confusing or if that doesn't help, please let me know, and I am happy to clarify any more if you need it. Thanks so much.